All right. Good afternoon, everyone. Welcome to this session on GraphQL and Java. How many people are currently using GraphQL? Just a quick show of hands. Anybody? There's got to be at least one person. One person, okay, at least one person. Oh, somebody else admitted to, okay. All right, so what we're going to do in this session today is we're going to talk about GraphQL first. And since very few people raised their hands, we'll do a quick introduction to understand what GraphQL is and how it relates to REST and what it means for building APIs. And then we'll look at a couple of implementations in Java to give you an idea of how you can build your own GraphQL server. Okay? My name is Pratik Patel. I work at IBM as a developer advocate, a Java champion, and all the other things, including the founder of the Perl recovery group. So how many Perl programmers do we have in here? Anybody still do Perl? No? Okay. A couple of people. So the Perl recovery group meets after this session at the bar, if you want to come, okay? So I did Perl for way too long. Anyways, so if you don't know, IBM is a massive contributor to open source Java, both through the Eclipse Foundation and also through the Apache Foundation. So you probably have heard of some of the things that we do, but one thing I want to highlight is in the top left corner here, we have an amazing low-resource Java virtual machine that's called OpenJ9, which is 100% open source and also 100% free. I don't know how we make money from it, but we're supposed to promote it. And it's a great VM, especially for cloud workloads. It's worth checking out, and all the other things that are on this slide. All right, so this is what we're going to do. We're going to go into what's GraphQL, do an introduction of that, and then build up a GraphQL server, look at some examples, and see how all this can come together so that you can build your own GraphQL. All right. So let's start with GraphQL. What is GraphQL? So you could probably guess based on the name, it's the graph query language. So unlike other types of models, it is based around a graph type of topology, right? So if you use a NoSQL database like Neo4j, it's a graph database. GraphQL closely mimics what we would do in the Java world when we build object-oriented applications, right? So when we do domain-driven design and we build an object model, we're essentially creating an object graph. And GraphQL is essentially a query language for an object graph like this. So it actually works quite well with Java. At this point, you might be thinking, well, not another language, right? I already know, as a developer, I already know 5 or 6 or 10 or 20 different languages, and now I'm saying that you need to learn another language. Fortunately, GraphQL is fairly straightforward and is relatively easy to pick up in terms of the base of the language and how we put things together with it. But first and foremost, GraphQL was designed as an API query language. So it's something that was designed specifically to build APIs on. And I think that shows, as we look at the examples, I think you'll agree that it is indeed very nice for building APIs. And again, the emphasis is on APIs, right? Unlike REST, which is kind of just naturally came about in terms of the way it's structured and how we use it. GraphQL was designed from the ground up for APIs. So it was created by Facebook, and it was open source in 2015, so it has been around for a while, okay? So it's not anything new yet, maybe new to the Java world because it's more widely used in the JavaScript and Node communities than the Java world. But GraphQL is not necessarily an implementation, but it's more of a specification on how you build clients and API backends using this specific spec. So anyone can implement a GraphQL implementation on the server, and we'll look at 2 implementations for Java specifically a bit later on. Okay? Now, you might be thinking, all right, so we just finished rewriting everything in REST, and now you're saying that we need to write our API backends in something different in GraphQL. The answer to that is yes and no. So one of the nice things about GraphQL is that it's just another tool in your tool belt. Okay? So yes, you can continue to use REST. And in fact, if we get a chance, we'll look at how you can take an existing REST API and put GraphQL on top of it. So it's possible to actually use REST and GraphQL together, or have GraphQL sit on top of REST. So you don't have to lose the investment and all the hours of work that you and your team have done on building a REST API. Okay? And to be honest with you, GraphQL is not necessarily a pure replacement for REST. As we go through some of the slides, hopefully that will become more apparent. All right, so we can wrap our REST APIs on and put a GraphQL server on top, and this abstraction is actually really handy and works well for a lot of use cases. Okay? And one of the interesting things about GraphQL is that you can have anything underneath it, right? So typically what we'll do is we'll build a GraphQL endpoint, create a schema that points to a database, right? Usually just a standard SQL database. But it doesn't have to be a database that's the thing underneath. When we look at an example in a few minutes, we'll look at one where it actually just uses some service that goes and calls something, makes an HTTP call and pulls some data, but we wrap that all into a GraphQL API. So again, the point behind GraphQL is to build a cohesive API that allows us to have a lot of flexibility and some other benefits. Okay? Now, one thing that's interesting about GraphQL is that when we build a RESTful endpoint, we have multiple different endpoints in a RESTful application, right? We may have /users, that points to users. We may have, I don't know, /shopping cart, and that points to a REST API for a shopping cart, or whatever, right? So we have different URIs that we use when we're building a RESTful endpoint, which loosely map the data underneath that we wish to expose to our client applications. In GraphQL, we only have a single endpoint. And that single endpoint contains all of the different types of objects that we wish to expose through our client API. Right? So this is one of the key differences, is we don't have multiple endpoints in GraphQL. We only have a single endpoint. And of course, that doesn't mean you only have a single endpoint for everything in your organization. You can create different GraphQL endpoints for different applications or features or however you wish to do it. Right? As a developer, we have the ultimate responsibility and the power to be able to design our GraphQL endpoints the way we want them to look. And we can have multiple endpoints if it makes sense. Okay? But typically, when we think of a single application, right, if we think of something like a standard kind of online shopping thing, we'll have something like /users, and we may have something like /products, and maybe /user profile, et cetera, et cetera. So we use all these different RESTful endpoints to expose and encapsulate the objects that are underneath. In GraphQL, for that single application, we will just have one entry point. But if we have some other application that requires its own GraphQL endpoint, we can do that. Okay? We don't necessarily wrap everything under a single GraphQL endpoint. And the other thing around this is, unlike REST, GraphQL is schema-based. So we actually have to produce a schema as a developer, right? So we actually have to go and say, this is what our schema for our GraphQL API looks like, and we have to write that schema. Well, we don't have to write it. We'll show a tool a bit later that allows you just to annotate for example, your JPA domain objects in Java and say, expose this book class or this user class with these specific properties inside of it, so that we don't have to write a schema if we don't want to. It will generate one for us. Okay? But nominally, GraphQL is a schema-based endpoint type architecture, and we'll see why that's important and why that's a good thing, actually. Okay? All right, so let's hope the demo gods are kind to us today. Let's do a quick demo of a GraphQL front-end endpoint. Okay. So what I have here is, this is a tool called Graphical, right? Graphical, and this allows us to go and basically experiment and investigate a GraphQL endpoint. So here I have query, I have the starships collection, and then we have starships inside of it. So let's actually get rid of this for now, and let's go run it really quickly. Okay, and you can see we have our data is returned, all starships, and here's a list of all the different starships in the Star Wars universe. Now, if I go back and put the model in and rerun that, you'll see that the Star Destroyer is an Imperial I-class Star Destroyer. Okay, that's great. Let's see what other data we could add to this. All right, let's see length. All right, so what just happened? What I did is I went to the editor here, and I hit Control Space, and that basically allows me to see all of the properties which are contained within this specific object. So let's see let's see how big the crew and the length of each one of these starships is. All right, so you probably know a CR-90 Corvette is a smaller starship. It has a crew of 165, and a Star Destroyer has a crew of 47,000, okay? But that's not the important thing is those specific numbers, but the way that we're able to go work with this API, right? So let's go and do a couple more things here really quickly. All right, let's see what else we got here. Let's scroll down, and wow, there's a lot of different things here. Let's go down to this film connection. Let's see what that is, okay? So I'm in my Starship, and in my film connection, I'm going to say, what films does it appear in? Okay? So obviously on the server, I built these objects and created some kind of relation between them, and I can expose this relationship through a GraphQL endpoint if I want to. So let's go run this, and now we'll see that we have our Starship still, and then we'll see this film connection and the films. So apparently the CR-90 Corvette appeared in these 3 movies, and then the Star Destroyer, if you are a Star Wars buff, you will recognize that it was in A New Hope, The Empire Strikes Back, and The Return of the Jedi, right? And so we could continue to scroll down and look at some of the different ones. This looks like the Millennium Falcon. Well, that's probably been all of them now. But you get the general idea, okay? So we're able to traverse a relationship also as we go and explore this GraphQL endpoint. Okay, so let's do this as well, actually. Let's get rid of this film connection for now. And let's make sure I get my, oops, not that, keystroke. Let's also do this. Let's go to all species. And let's go find the species, and let's just do the name of the species. All right, so what I've done here is I'm looking at 2 different objects concurrently. I'm looking at the Starships object, which we just looked at, and I'm also looking at the species object. But those are 2 completely different objects. There's no relationship between Starships and species. Let's see if this works. Okay, so here's our Starships. I'm just going to collapse the Starships, and here's all the species: human, droid, Wookiee, Ewok, et cetera, et cetera. So this is what the key difference is between GraphQL and REST. In a RESTful endpoint, if you go to /users, you typically will only get users out of it, right? If you go to /products, you only get products out of it. Well, the nice things about GraphQL is that you can query different objects and return them in the same call. And this is nice because now, unlike a RESTful endpoint, say you need to go get the user's profile. You go to /user profile in a RESTful endpoint. And then you also want to get everything in their shopping cart, then you would have to go to /shopping cart. And you also want to load in their product, /products. So now I have to make 3 calls to go and populate a page when the user first comes to my web shopping portal or whatever, right? So I have to make 3 calls to fill in those 3 different bits of data. If you think of like something like Amazon.com, they go and grab your user profile, they show you what are the featured products, and they go and grab a few other things, right? And they make multiple calls to do that. What we can do with the GraphQL endpoint, however, is we can make 1 call and we can get everything we need, which is really nice. Okay? So instead of making a separate call to get Starships and another call to get species, I can make 1 GraphQL call, like I've shown here, and we can go and get everything we need in 1 call, which is super nice. Okay? So let's have a look at a few others. And I'm going to cheat now and go into my history because I can't remember all of them, all this syntax off the top of my head. Okay. We can also have modifiers inside of our GraphQL. So you can see we're still traversing the Starships here. And let's get rid of model. Let's clean this up a little bit, make it a little nicer to look at. And what I want to say is I want to see the first film that that specific Starship appeared in. And you can see that the CR-90 Corvette first appeared in A New Hope, and a Star Destroyer first in A New Hope. Of course, A New Hope was the first Star Wars movie, so pretty much a lot of these will be A New Hope, and then it looks like the Executor. I don't even remember what that one is. But anyways, you can see we applied a modifier here to say just go get the first one, right? In case we want to just fetch a certain amount of the data, or let's say we want to get the first 2. We go run this. You can see we'll get the first 2 things in that collection. And of course, we can go and apply this same thing to here. And okay, hopefully this works. I don't think I've tried this before. Yay, it worked. Okay. So Starships, here's the first one, and here's the second one, right? So we can do pagination like this as well, right? You have to write the support for something like pagination in GraphQL, but it is possible to do and is supported in the specification. Okay, let's have a look at a couple more things here real quick. Okay, we did the species one already. We looked at the connection. One thing that we can do as well, let's actually do one more real quick. Let's look at this one. Okay, So one other thing we can do is we don't want to do string concatenation. Let's say we're building a web application that's going to consume our GraphQL API. We don't want to do string concatenation to go and build our GraphQL that we're going to send to the server. So we have this possibility of putting in what are called query variables. Okay? So you can see I have Starship ID as part of the query variables, and if you're using a JavaScript GraphQL client, it will know how to go and do this. It will take something for your actual query, and it will take a section for your query variables, and then merge them together as appropriate. But you can see I'm using $Starship ID, which is of type ID, and then I go use this inside of this query. Let's go make sure this works. Okay, so the Starship ID I'm not printing out here, but I could. So let's go print the ID out real quick. Okay, all right, so there's the ID, which, as you can imagine, matches that query variable, right? So there's this ability as part of the GraphQL specification that I can have query variables that will get injected into my actual GraphQL query or mutation based on this $ syntax that's right here for going and querying certain parts of our GraphQL API. Now, if you remember, GraphQL is based on a schema. And anytime you have a schema, what are some other things that you use that has a schema? Anybody? Database, thank you. Right? Let's talk specifically about a SQL database. SQL database has a schema. And you probably use some kind of tool when you're looking at your SQL database that can go and get the metadata from a SQL database and give you build like a nice chart for you, or do some kind of inference when you're writing out SQL queries by hand. Similarly, what we can do, because GraphQL has a schema, we're able to go and explore that schema. In this case, GraphQL or Graphical supports it. And you probably remember when I was over here on the right, I was able to hit Control Space, and it would give me this ability to go and essentially look at the schema. Well, we can also go browse the schema like so. So here's our film connection. Okay, so these are different films. And then if I go into here, I can actually go and look at the different properties of the film class or film object. It's got a title, it'll have an episode ID, who's the director, right? Which species appeared in that specific film. So there's a connection between those two, what vehicles, et cetera, right? So we have the ability to go and actually browse our schema so that we can understand what is contained inside of it. Okay, so we have vehicles, other things like that, right? And this is super nice. So especially if you are looking at a endpoint which you've not worked with before, and you have a new team member, and you say, oh, just go look at the GraphQL schema. This is where everything is. Okay, so this is really nice. The ability to go and actually look at the schema and also play with it using something like Graphical, this tool that we've been using to do this. All right. So let's just do a quick review, right? We did this, get starships as they appear in the film. We didn't do this, but we could have done a total count of all the starships that are contained inside of this, right? And do a query using specific ID, and then use query variables as well. Now, one thing to note at this point is that you have to build all the capabilities on the server that you want to build. So in this example, someone went and built this graphical or this GraphQL endpoint, which has starships and has species, and they implemented total count, and et cetera, et cetera. So someone wrote all the code to be able to go and look at those different objects, which are in our data store, in this case, for this specific GraphQL endpoint. So you as a developer, you have to go write that. So say that you want pagination, you have to write support for pagination. Say that you want to get a total count of all the books which are in your library. You have to write some kind of method or something that will go and do a count of everything and return that, and we hook that into our GraphQL schema. But don't worry too much about that just yet. We'll look at a hard way and an easy way of doing that in just a minute. Now, one thing to note is you probably saw that I was going and getting all the fields individually, right? Like the title, which movie did the starship appear in, et cetera, et cetera. So let's go back into here real quick, and we'll just pick a simple one here. Oh, not that one. Okay, just want a simple one. All right, so I have name, model, and of course if I hit Control Space, you can see there are all these different things I can do. Okay, let's see what happens. I want to go get everything. Okay, so let's see what happens if I do star. Cannot parse unexpected character that. It's interesting. How do I go and get everything? All right, let me see if this gives me any hint. This gives me no hint as to how do I go and get all of the fields that are in this specific object. Right? I don't know, maybe do this. Okay, well, it doesn't look like I can. Right? And this is one of the interesting things about GraphQL is that there is no wildcard character for going and fetching things. Right? So you can't go and get every field in an object. You have to be declarative and say, I want the date that starship was created, the name of it, how big it is, blah, blah, blah. You have to specify exactly all of the different things that you want out of an object. And this is actually a deliberate choice. There is no wildcard to go and get everything. You have to type everything out by hand for the things that you specifically want to get, right? That's quite different than a RESTful endpoint. Because if you think of a RESTful endpoint, if you say, give me /users/1 or whatever, you get all of the information that is contained at that RESTful endpoint. If you do /product and a product ID, you get all the information that's contained within the product when you're building a RESTful endpoint. Okay? In GraphQL, you can't do that. And so at this point, you might be thinking this is like, well, how is this even useful if I have to go and type everything out every time I create a GraphQL query? Let's talk about that in a little bit more detail. Okay? In GraphQL, you only get what you asked for. You have to be explicit and declarative about exactly what you want. Okay? But as we saw previously, we can say, I want something from here and I want something from here. Those two things may not be related, but you can make that all in one API call. Right? And these are some of the advantages over REST, right? Based on what you've learned so far, right? Being explicit and being able to get things from different collections, if you will, right? So REST has the problem of overfetching. If you have, let's say, a product object and it has 50 fields inside of it, when you go get that specific product, you're going to get all 50 fields whether you want them or not. This is commonly referred to as the overfetching problem. And also in REST, like I mentioned earlier, say you want something from a product and you want to go to /shopping cart or /user profile. You have to make two calls to get those different objects. There's no way to programmatically traverse them unless, of course, you wrote a separate RESTful endpoint called /user and products or user and something, right? So you'd have to write a separate thing to be able to go and get things that would normally be at two different RESTful endpoints. And this is one of the other advantages over REST is that GraphQL solves the underfetching problem where you can just make one call and get things which are in different collections. Right? Of course, in REST, you could write a new endpoint that is the combination of two different endpoints, but then that means you have to do work, and that may be work that you don't want to do. Right? So the other thing is that if you have to make multiple calls, especially if you're a web developer, right? If you have to go get something from this endpoint users and then this endpoint /products and from a RESTful backend, you have to go and serialize those calls. Right? You have to do them back to back, and that can lead to what, if you're a web developer, you've probably heard something called callback hell. And even with the newer versions of JavaScript, by using async await and et cetera, you still have to be careful and you have to write code that may become a little bit complex. All right? And similarly, we so far have just been talking about fetching. We could also write a GraphQL query, well, specifically mutation, that can go and update two different objects also, right? So we can fetch data from two different objects, and we can also go and update two different objects in the same GraphQL query or mutation, right? Whereas in REST, we typically would have to make two calls to go and update two different things, okay? All right, so because of these reasons, some people will say GraphQL is faster, and some people will say GraphQL is simpler. And the reason why I have that in quotes is because it depends on how you look at it, right? There are certain cases where REST is actually simpler, and there are certain cases where REST is actually faster. So for example, when you're building a RESTful API and you have RESTful clients, REST, it makes it easy to do caching against the data that you have in the back, right? GraphQL is normally harder to cache because of its kind of layered schema and things like that, right? So anyways, you decide for yourself if you think it's faster or slower. Okay, but let's talk about wildcards a little bit more. So you may not be convinced at this point that having to type everything out is a good idea, right? Maybe too cumbersome. Maybe you don't want to do it. Too much work. Right, let's say that server-side developer goes and removes a field that exists inside of your product object. Now, all of your clients will now need to be updated to reflect that. But what if you work in a big company or you have a lot of different teams and you don't know that that specific field has been removed? How do you update that and how do you keep track of those kinds of things? So what will happen in GraphQL is that when a field is removed in a GraphQL server implementation and then you go and try to query this, so let's say that we used to have a field called color inside of our starships. Okay? But we decided we don't need this attribute anymore. We're going to move it somewhere else. Now, if I try to go and run this, you'll see, let's make sure this works first. Okay, there we go. Right? So let's say we remove that color from our GraphQL server and we go run this. You can see what happens here. We actually get an error back. It doesn't fail silently. So assuming that you have unit test and integration tests against your clients that are hitting your GraphQL server, you will actually get an error, right? It's not something that just magically disappeared, and now you're trying to figure out what the hell is going on. You actually will get an error that says, I don't know what that field is. And then you call somebody on the GraphQL server team in your company and say, hey, you could have sent me an email that you removed that field or something like that, right? But it's an explicit error, which I think is good rather than bad, because the worst kind of error is one that just fails silently, and you have no idea what's going on. All right, similarly, if you were using wildcards, let's say that the GraphQL server engineer goes and adds a new field or property to that object. Now, let's say that that field or property is something that is a connection to another collection. So you're actually now getting this object that you wanted, and you're also pulling in this massive collection that's behind it. Okay? So again, in GraphQL, you have to be explicit about everything you want. So your GraphQL client will keep working, but you may get an email or during your Agile stand-up meeting or whatever, the GraphQL server engineer will say, oh, by the way, we added a connection from starships into species or whatever. And so if you want that, you would go and update your GraphQL query. But if you're using REST, you may go inadvertently pull in this big data collection that's behind the object that you're looking for. Right? So again, it's about being explicit and declarative. And it helps with both avoiding errors and also with making sure you get exactly what you need and you're not pulling in too much data. Right? Overfetching and underfetching. Okay? So one of the things I like to say is that as a developer, as you build applications over time, you find that you want to avoid magic. At least I do. I don't like to have magic. Sometimes a little bit of magic is good. But having too much magic means I don't understand what the hell is going on underneath. Or when I'm building something and it blows up in my face because some change has been made, maybe I made the change like 2 weeks ago and I just forgot about it. I don't like that magic. I like for things to be explicit so I'm able to troubleshoot, diagnose, and move on. Right? So avoiding this magic is helpful because the app breaks in obvious ways. And as discussed before, if we're explicit about what we want in our GraphQL query as compared to REST, we don't have to worry about overfetching or getting a lot of stuff that we just don't need, that we may not notice, right? Because the back end has changed and maybe another team is doing that. Now, you might be saying, well, it's going to be a lot of work to try to go and write out all of the different fields for the object in these 10 or 15 or 50 different places that I'm going to be getting that Starship object, or maybe I go to get the user profile object or whatever. What we can do to help with that is we can use something which are called fragments in the GraphQL specification. So that means this, right? So we could create something called a user fragment, because we know that we'll always want to get an ID and a username and maybe email address or whatever. So we create a fragment, and then we can reuse that fragment in multiple different places. Right? So we could create a fragment that has every field of the that's in a user, and we can use that where we feel it's appropriate, or we may just want to get small parts of the user, so we can create a different user fragment that has the 3 or 4 fields we need instead of the 10 or 20. And the way that we use that fragment is when we create a user, we would say ... user fragment, which will go and pull this in and allow us to not have to type out those fields every time. Okay? And additionally, if, for example, there was something in here that got removed, this user fragment would obviously come into here, and we would no longer have that thing once we removed it in one place. So it's basically one place where we can go and declare different types of fragments for an object we wish to use, and we're able to not have to write everything out every time. Okay, so far we've been talking only about going and doing queries, right? Getting data. How do you make changes in GraphQL? We use something called a mutation to do that. So, for example, to do a mutation, we would write this kind of code and say, this is a mutation. We want to run the save car thing underneath, right? We don't know what it is. It's just something provided to us by the API. This is the car object, and then when you're done with saving this car object with the name of this, this curly brace here and this curly brace here says, return me whatever is inside of here. Maybe I want to get it, right? Maybe in this case I want to get the ID once the car has been saved. But what we do is we use mutations to go and update data inside of GraphQL API. All right. With that, let's go and look at GraphQL and Java. Right, there are a couple of different libraries that we'll talk about. The first one is a low-level library called GraphQL Java lib, or just GraphQL Java. And then we'll look at GraphQL SPQR, or GraphQL Speaker, as the 2 different ways that we can implement a GraphQL server. Right? And if you want to visualize kind of what this looks like, we could have a database underneath. Maybe we use JDBC or JPA. We write some GraphQL code using those JPA entity objects, and that helps us construct a GraphQL endpoint. All right. So, again, what we have underneath can be an RDBMS, or it can be anything that you want to expose. It doesn't have to be a database necessarily. And the one thing to remember is that we're defining an API. We wrap anything you want as the developer. It's up to you to write that code to do that. All right, so let's do another quick demo. And let's have a look at the first implementation, which is the GraphQL Java library. So if I open up the imports, you'll see that I have a few different things I'm importing in here. Let's actually go to something more interesting. Okay. All right, so this is GraphQL Resolver, but let's start with the query. All right, so we're going to implement this GraphQL Query Resolver. We have something that goes and injects some base repository service classes, find all books, find all authors, count books, count authors. Let's go and start this server up in the background. I think it's running. Let's go fire it up. Okay. And if we go look at the documentation, let's make this a little bigger so you can see it a little bit better. Okay. Let's go to the Doc Explorer, and what were we looking at here? We were looking at the query, which implements GraphQL Resolver. So let's go into here, let's go into query, find all authors, find all books, count books. If I flip back to the code, you can see that these are the 4 methods that we're essentially exposing. So let's go look at find all books. So find all books calls book repository, which is this guy right here. And that book repository is just a Spring Framework CRUD repository. And if we go look at book, this is a standard JPA entity class, and you can see here are different things. But we do have a relation to an author right here inside of it. So how do we create in GraphQL that relationship? We have to create what's called a resolver, and you can see book resolver implements GraphQL resolver, and inside of that, here is my get author that we use to go and traverse that specific relationship. Okay? So go back to our query. We go and say GraphQL query resolver. We have our repository objects, find all books, find all authors. We go and grab the different things from the repository, and then the framework does some of the code for, or some of the work for you in terms of what's underneath that. Okay? And if we go look at mutations now, similar thing. Go back to here. Let's go back. Let's look at mutation. And I don't want to cover all this, but let's just go look at new author real quick. Okay? So here's our mutation object. It implements GraphQL mutation resolver, which is a base class that we need to implement. And then if we go look at new author, you can see we have public, new author, name, et cetera, author repository.save. Okay? So this is using a low-level library. We use GraphQL mutation resolver, query, GraphQL query resolver. Okay, and if we go look at the actual application now, right, so this is a Spring Boot app. I'm assuming most people are familiar with this. Right, we have an error handler here, and then what we have to do is we have to additionally go and construct these things. So here's our query, here's our mutation that we have here, command line runner if we want to do that, but this basically goes and gets injected into our main class, and this is how we expose. The library also is doing things underneath the hood to specifically create that GraphQL endpoint that we were looking at. But this is how we go and put the beans into here for this book resolver that we're going to be using to go and query stuff out of it. Okay, so this is the error resolver, et cetera, et cetera. And this is a perfectly fine way of doing this. Okay, it's not too difficult. We haven't really built anything too crazy here, but we had to do a lot of manual work, and we had to write like a lot of classes and things like that to be able to do something which is relatively simple, even in this very simple example. Right? So what we'd prefer to do is there's another library, well, at least I prefer to do this. There's another library called GraphQL Speaker, so let's go have a quick look at that. Let's go stop this one, and let's start this GraphQL Speaker example. Okay. It'll take a second to fire up. Okay, I'm just using a local HQ database underneath the hood for this. Let's go get rid of this. Let's go reload this. Let's get rid of that. And now I'm going to comment this back in. Let's make sure this works really quickly. Uh-oh. Oh, okay, good. Thank God it worked. Okay. So we have our cars, name. We'll talk about this Giphy URL. Is it true? So let's go look at the code now. And how do we build this specific thing? All right, switch projects real quick. All right, so let's start with car. So here's car. Here's my JPA entity object. And because I'm extremely lazy, in this case what I'm doing is I'm using Lombok. How many people have heard of Project Lombok before? Okay. Oh, okay, that's good. Everyone has. It's nice. I don't have to explain all that in that case. All right, so you know what all that stuff is. But what we're interested in here is at GraphQL query. So you can see I just go into the entity object directly and say at GraphQL query, add this whenever this thing is exposed. This specific entity object is exposed with ID and a name. Okay? So now if I flip back into here and go look at our docs, my car, right? You can see I have these three things. So that's interesting. Where is cool and Giphy URL coming from? Huh. Because if you look at this, I have an ID long, right, which is this right here, and then I have the string name. Right? So if you remember what I was talking about earlier, with GraphQL, we as the developer decide what we expose through our endpoint, what data we want to expose and how we want to expose it. And it can be a JPA object, or it can be something different. So let's have a quick look and see where those things are coming from. Okay? So let's go look at our car repository. Nothing fancy here. Okay, we looked at the car already. Right, application web config. This is how you set up the graphical endpoint that we're looking at right here. We basically have to go and slap this class in and add a view controller to our Spring Boot application that exposes GraphQL like so. But let's get back to what we are doing here. Okay, and this is our Spring Boot application. Initialization, I'm just going and creating some, that's the Ferrari, Jaguar, and everything that you saw here. Let's get rid of this. right? There's a Ferrari, Jaguar, et cetera. So I just went and injected some data in quickly. But let's go look at the actual GraphQL controller. Okay, so we have our GraphQL controller here, and we can use a schema builder or this specific GraphQL controller here, right? You can see it's annotated as REST controller. We say we want to use the annotated resolver builder, so that goes and scans our class path and basically produces our GraphQL endpoint or builds our GraphQL schema for us. And we say do a post mapping for /GraphQL. And this is where we use the schema that we just built. We say go and get the queries, operations, build, etc. Okay? So this is where the entry point is. This is where we go and build our actual GraphQL server based on the incoming values. Okay? Now, let's quickly go and see what's happening with that car. So let's jump into car service here, right? Because this is what everything is exposed to. So we have our standard repository object, and we can say GraphQL query cars, go and get all the cars. GraphQL query, when we get the car, this is what we go and get. Now, what we're doing here is we're saying also go and inject this GraphQL query. Actually, we're dynamically adding a new field to it called isCool. And you can see we use this other annotation called @GraphQL context against car. So similarly down here, we have GraphQL context car. So what this is doing is this is augmenting that base JPA entity class with just another property on top of it. So we're telling the GraphQL API, this is our entity object, or this is our base object right here. Okay? Here's GraphQL query, including the GraphQL query for this object of car. Include this thing right here, name. But we can also go do this in our car service, where we say, as part of the GraphQL query that we're constructing, create a new field called isCool and Giphy URL, set it against the car object like so, using @GraphQL context. Okay? And let's go look at this Giphy service. What is this thing right here? Right, so if we go into Giphy service, what we're doing here is, right, we were calling get Giphy URL. Well, where'd it go? Sorry. Right? We're calling Giphy service.get Giphy URL. Okay? And we have get Giphy URL, et cetera, et cetera. And what this is doing is this is basically going and hitting Giphy, and we pass it in. We're making an HTTP call here. What we're doing is that's why the server took a second to start up. When it was actually starting up, it went and created all those objects, and in the process of constructing the GraphQL endpoint, it went and actually made these calls to Giphies and injected, well, maybe injected isn't the right word, it went and created these different Giphy objects. I wonder what this one pulled up to like this time. Let's see if this works. Oh, okay. I guess that's a Ferrari, all right? But anyways, you get the point, I think. What we did is we created a standard JPA entity object. We went and said we want these two things to be in the GraphQL schema that we exposed for this. And then inside of a service, we said, well, we also want to add an isCool property and a Giphy URL property to it. And you can see how this isCool works. We say, if the car is one of these, then it's not cool. Otherwise, it's cool, whatever. Okay? So we're able to go and dynamically do that. Now, how do we create a GraphQL mutation? So we have @GraphQL mutation. The name of this mutation is save car. And then this is save car, GraphQL argument. Let's create an argument for this specific GraphQL mutation. We're going to call that argument car. It's going to go into this car object, and we'll do car repository.save of car. Okay? Similarly, if we want to delete a car, we say the argument should be the ID, car repository.delete by ID. Okay, and we have a few more here. We can go get a list of cars, get a specific car, et cetera, et cetera. Right? But this is a much nicer way of creating, going and creating a GraphQL endpoint. And of course, the schema is generated dynamically here. Right? Like, actually, one thing I forgot to show. Let me flip over to the previous example very quickly. Right? And let's look in this directory right here. You can see in the resources directory, I have GraphQL. Again, this is the previous library that I was looking at, the kind of low-level GraphQL Java library. And if I open up author.graphql, you can see that we can also type out our GraphQL API in the schema for it like so. Right? We can basically just write this schema out like this, and then we would use Again, as we saw in the previous example, we would use this to drive the actual code that's underneath. Okay? But let's get back to our current example. Right, there's really not much else to show here, right? This is how we build the schema. As I mentioned previously, we inject the car service. This goes and resolves everything by scanning the annotations and building up a schema for us dynamically. Okay? I have a couple minutes left, so I'm going to skip ahead a little bit. All right, so we used annotations using GraphQL Speaker. We've seen how this works. All right? We use @GraphQL query for the annotations. Go and do that as well. And it's the same slide. Okay. So in terms of what kind of app server you can use on the back end, it can be anything. Because GraphQL Speaker is its own library. You can use it in Spring Boot, or you can use it in a microprofile server, or we can just run this from the command line if we wanted to. Okay? It's up to you. So the back-end server that you actually use can be anything. Tomcat, Spring Boot, Netty, maybe using Open Liberty with microprofile. You can use anything to build that server out with. Right? There's some things that we didn't talk about in detail, but I should at least mention them. One thing is we didn't talk about how we do authentication and authorization, right? But of course, this is possible in GraphQL. We just have to write an endpoint that goes and checks for the cookie. Maybe we use some kind of middleware to do it, right? Maybe we use an API gateway to ensure that the user is logged in and stuff like that. It depends on how you implement it at your company or how you wish to implement it. We didn't go into too much detail about pagination either because we didn't really have much time to do that. Okay? We looked at mutations briefly and how to do changes. I think I have a mutation here, actually. Let's go run one real quick. Okay? So let's comment this out for now. Let's comment this out for now. Okay? So if you remember from the example that we were just looking at, right, we said mutation, Tesla Model S Extreme. Let's make sure that doesn't exist here yet. Okay, it's the only place it exists. So now if I go and run this, you can see that I said I want the ID and name back. Let's say we just don't want the name at all. We just want the ID. Let's change this to Tesla Model 3. Right? That's the new one, I think, right? I can't remember. Oops, not that way. Oh, great. Okay, let's go run this real quick. And you can see I'll only get the ID back now. All right. Let's go back to our slide real quick. We're almost done here. Actually, we are done with 30 seconds left. All right, so I don't think we have time for questions up here right now, but if you do have a question, please come up front. Happy to talk to you about anything you want to know about GraphQL if I can answer it. Thank you all for coming. Hope you enjoy the rest of the conference.